Good afternoon, everybody. This is Salim Khan, and today I'll be joined by Mr. Bob Townhoff, and we will be doing the Energy Efficiency Water and Wastewater Plant Design and Operation webinar. So we'll get going. So SECO Facilities and Infrastructure and Energy Management webinars. We have conducted 4 of them already, and today's webinar is Energy Efficiency Consideration for Water and Wastewater Systems. So just want to make sure that everyone is aware of the topic for today. So I'd like to welcome everybody. Thank you for taking the time and being part of this webinar. I hope you find some of the information useful. A couple of housekeeping items I would like to go over. We will have a PDF of the presentation, and that will be distributed to all the participants. The video recording of the presentation will also be distributed, but that usually takes another day or two, but it will be sent out. In between the presentations, there are at least 2 locations where we will be doing some polling, so you can provide your input over there, and then we'll give the results. You can ask the questions in between, but I think what we will do that has worked pretty well is that we will allocate last 10 to 15 minutes of the presentation to potential questions and answers. And if we can get to you today, then we'll make sure that we get back with you either after the presentation also. So rest be assured that all questions will be answered either today, and if it can be today, then soon thereafter. All right. Just a quick introduction. This seminar or webinar is part of the State Energy Conservation Office Local Government and Schools program. The program provides free energy assessment, training, and technical assistance to all those who ask for it. And then one of the main items of this program is doing a preliminary energy assessment, also known as a PEA. And the first couple of slides of this presentation, I'll be going over the PEA process and more tailored toward water and wastewater plants. And then the last and the next set of slides would be primarily on energy efficiency consideration for water and wastewater treatment plants. So me and Bob Townhoff are going to tag team this thing. So I'll take care of the first few slides, and then I'll have Bob Townhoff join us in. So. All right. Before we dig into water, wastewater treatment plant, energy efficiency improvements, and so on and so forth, I'd like to just go ahead and define an energy audit. Pretty much everyone knows something about it or a lot about it, but I think it's good to just go over the basic definition of an energy audit. So one of the first steps involved in an energy cost control of the facilities. So energy audit is used for cost control of the facilities, and an energy audit or survey consists of examination of how the facility uses energy, determining cost of energy for the facility, recommending operational changes, a lot of what they call low cost and no cost measures basically, and then recommendation for cost effective equipment upgrade, which are capital retrofit projects, and then generating a report or developing a report that kind of summarizes all the findings and the description of the project. So an energy audit, again, is one of the first steps involved in energy cost control of the facilities. Also, like to take this opportunity to kind of, there are different terminologies and different meanings of energy audit, basically, and I wanted to go over some of the common terminologies or names given to different energy audits and what are the main differences, basically. So preliminary energy assessment, also known as PEA. Some people call it preliminary energy audit or analysis. Some call it initial energy audit or survey. Some call it walkthrough survey and assessment. So those are different names that you will come across. Primarily, a preliminary energy assessment is a process in which we do the assessment of the facilities, but it doesn't go as much in depth as a detailed energy assessment would be. So a detailed energy analysis, also some called DEA. Some people call it comprehensive energy analysis, CEA. It is also called investment grade audit, IGA. And in the SECO Lone Star program, it is called utility assessment report, or UAR, basically. So the primary difference between the PEA and the DEA would be that the PEA is a quick walkthrough of the facilities and giving you a pretty good report, but not going into too much detail on the cost and calculations. A DEA is a more comprehensive report. A PEA normally will take anywhere from 30 to 45 days. A DEA could take up to 100 to 120 days, basically. So again, if you are applying for example, a Lone Star program, you're required to have a utility assessment report. However, the PEA that is developed, or you have that, you can use that to apply for the Lone Star loan. So a PEA is a good document to have. It will give you a little roadmap, and I'll describe the benefits later on. For those of you who are on the building side, they may have come across ASHRAE categories 1, 2, and 3. Mostly the ASHRAE category 1, 2, and 3 type of audits are geared towards facilities, buildings and so on and so forth, and not too relevant to water wastewater treatment plants. For example, the SECO PEA would be somewhere between 1 and 2, ASHRAE category 1 and 2, and a DEA for a SECO will be somewhere in the category between 2 and 3. So anyways, a preliminary energy assessment is an initial assessment, and detailed energy assessment is a more comprehensive process. So we have our first poll question over here. Have you conducted any kind of energy audit at your facilities in the past 3 years? And pretty soon the poll should be up, and then we will we'll review the results, give you a couple of seconds to answer, and then we will close it. Okay, we're gonna close the poll and give you the results. So it looks like 50% has conducted a PEA, 8% said yes, a detailed audit or investment grade audit has been conducted, 25% said yes, both a PEA and a DEA has been done, and 17% saying we have not conducted any form of energy audit in the last 3 years. So that's good to know, something we just were curious. All right, so the PEA process, and primarily I'll be describing the State Energy Office PEA process, but pretty much if you're doing a PEA on your own, similar steps are involved in it. So just wanted to quickly go over some of the steps involved in the preliminary energy assessment of the PEA. So the first thing is that you've got to send a service request. You contact SECO program manager, you contact the engineering firm assigned to the area, and you send this simple one-page form service request to the SECO program manager, and that's how the process starts, basically. So I believe what we will be doing is probably sending you all just an FYI, this one-page service request is a very simple request, but just in case if you're curious what it looks like, we'll be sending that with the handouts. You can also go to the SECO website and download it from there. So once you have done that, the next step is what we call is the need assessment phase. And primarily the need assessment phase is where we are trying to determine the scope of the project. So for that case, if there are a lot of buildings involved, we need to know the square footages of those buildings. And if you got water wastewater plants, then we want to know how many and general capacity and so on and so forth. So basic data that will tell us what kind of facilities we are going to be looking at it. The need assessment phase is primarily done because we have limited resources. So what we would like to do is that if you've got a lot of facilities, we cannot get to all the facilities. So this way we work with the owner to kind of prioritize which facilities needs to be looked at. And from time to time, occupants or owners have specific technical assistance request. They have a specific issue that they want to explore, and we will evaluate that and put it part of the scope. Once that is being determined, we send this approval to the program manager. Internally, it's done, and then when it's approved, we start the next process. So once the need assessment is done, we should have a general idea of what the scope is. Also, just an FYI, sometimes we do need assessment. Sometimes we're able to do it on the phone, and sometimes we have to go to the facility, do an on-site meeting, and look at a few things before we can nail the scope down. So it's done both ways. Then the third step in the process will be to gather data and conduct an on-site survey. So primarily, which is very crucial and important, is that we need to have all the electric, natural gas, and water data basically for the facilities. However, if your water wastewater plants, then you primarily will be more interested in giving us the electric and natural gas data. Primarily the electric will be the primary source of energy consumption over there. So once we have that, we like to get 12 consecutive months of the data, and a lot of time we are able to go to the utility service provider with your approval to get the data electronically from the electric utility company, and that's done very seamless, requires a signature approval from you all, but that could be done too in case you don't have the information handy. So once that is done, we will then conduct an on-site survey of the facilities, and typically in the PEA process, it might take anywhere from 1 to 2 days, depending on how many facilities we have. During that on-site survey, we'll be going through the facilities, looking at a few things, getting some feedback from the operators, and making some notes, basically. So once the on-site is done, then we will be, even when we are on-site, we'll be looking at the potential for different UCRMs. UCRM stands for Utility Cost Reduction Measure, basically. So while we are on-site, we are thinking of a few things that could be done. And then once we have done on-site, we've got some basic data, then we are back in the office and we spend some time doing the analysis. One of the outputs is the Energy Performance Index, which primarily, I'll describe it in a little more detail in a second, but that is very fundamental to what we do, and that becomes also the baseline for your energy consumption profile, if you like to have it like that. Then we, in the analysis phase, we'll be doing some cost and saving analysis for different measures. So once that is done, the next step is that we start working on the report development. In the process, there might be some more communications with you all to get some feedbacks, run some ideas by you guys, but mostly we'll be doing this stuff in-house and taking care of a lot of these things. So the report primarily would have a baseline of your energy consumption profile. It will identify O&M measures. It will also have utility cost reduction measures implementation plan, basically with cost and paybacks. We will also look at, if you have an energy management plan, we might have if you don't have one, we might have a suggestion for what you could have in an energy management plan, and if you have one, we might be providing you some feedback on upgrading or updating that. So the report will touch base on those aspects of it, and then also the report has funding options outlined in there too, how you can fund these projects. So those are the things that we're looking in the report, basically. Then once the report is done, the PEA is presented to you all, and we discuss each section of the report in more detail, discuss funding options, and then give you any feedback on next steps. So just want you all to be aware of that. Okay, so one of the main things of while doing whether it's a facilities or water wastewater plan, what you want to do is establish some baseline indices, basically. So in the water wastewater plant, it is energy use index, also known as EUI, which is the annual energy usage divided by average effluent flow, or KBTUs divided by gallons per day per year, basically. So once you have given us that data, that is one of the things that we will be putting together and putting in the report. Very useful information and fundamental to doing any energy audits. Also in the report will be energy cost index, which is the annual energy cost divided by average effluent flow. You know, we'll be taking care of that information also and presenting it in the report, which is $ per MGD per year, basically. So the energy use index and energy cost index for the facilities that we looked at will be part of the report, and you'll be seeing that information. Key thing to remember over here is that there are a lot of factors when you're looking at water wastewater plants, unlike buildings where you could probably be doing, you know, without doing much of a normalization. In the water wastewater plants, there could be biological oxygen demand requirement and permitting requirement that you need to look at. So if you're comparing one plant from one plant to another plant, you need to have some other additional information to actually do comparison between, you know, you don't want it apple and oranges, you want to be looking at the same stuff. Just want to let you all know that there are a lot of normalization factors involved in the water wastewater treatment plant. Okay, so once we have that information, so what you will see in your report, what you see on the screen over here, it will give you wastewater treatment plant A, B, C, D, and you will have the EUI and energy use index, and ECI, the energy cost index for those plants, basically. So that information will be there that could you use as a baseline going forward, and then ideally you will be comparing this from one year to the next year to keep track of how you're doing, basically. In the PEA, we touch base on some initial kind of utility rate analysis. And primarily, we might be looking at if there are factors that might be impacting your facility. So if we can get that information, we can provide some feedback to you all. For example, in this specific case, you know, where you see the power factor analysis, so apparently there was a power factor penalty that was part of the utility rate, basically, and that way we were able to zoom in and see what we can do to eliminate that penalty. So those are the kind of things that we'll be looking at it. Most importantly, over here also, we like to do electrical demand analysis, which is the KW, which is the peak power draw, and a demand charges. So we like to look at how you are doing on your demand side, and demand is almost a very large portion of your utility bill. So we like to look at that aspect of it. Not very important, but most important for the buildings, probably not that critical for water wastewater plants, but we also do load factor analysis that tells us the consistency of facility usage. So typically, if you have load factor over 40%, that means you're using things after hours and so on and so forth. So those are the kind of things that we are looking at as we are doing PEA. So And facility site visits. So what are the kind of things that we do during the facility site visits? And most people have asked us as to what kind of commitment does the owner need to have, and for how long to help us in the site visit. So typically a facility site visit, we'll do an initial meeting. We'll meet with the operators, engineers, director of maintenance, operations, discuss plant operations and concerns. So typically an hour meeting, 45 minutes to an hour meeting, and then followed by a walkthrough of the facilities. So we primarily might need an escort to just be able to take us to different facilities, and we may have a couple of questions as we go through it. Typically, again, in the PEA, this will be a 1 or 2 day kind of a time frame involved in it. And as we are going through this thing, we'll be taking some notes, identifying energy saving measures or potential energy saving measures, and taking some notes and you know, asking questions and so on and so forth. So anyways, the facility site visits is a pretty straightforward. It's all coordinated, work through you all, making sure that you all are available, so we work around your schedule to make this thing happen. So general maintenance and operation considerations that we are looking at when we're doing this initial site visits or preliminary energy assessment, we like to look at low cost, no cost measures that we can recommend that you could implement, and without spending much money that you can save some energy. So we may have some suggestions in that regard. We talk about how the routine maintenance procedure and schedules are. We may have some input on that. We also look at equipment scheduling, the set points, see what kind of control points are you controlling to. We like to have some information on that. We might be looking at your front end SCADA for a little while, but primarily we are just going through and making some notes. Also, we'd like to know more about the operational procedures, why you're doing things the way you're doing them. Obviously, the main thing is that you want to keep the permit active, but we just like to get a feedback on how you're doing things. And then I think we are also looking at, a lot of people ask us for guidelines for energy, you know, for efficiency levels of the future equipment purchases. So that's something that people ask us, and we address that from time to time. So these are the general considerations which are related to operation and maintenance of the plant. One of the other things we also ask during this process is that, do you have an energy management plan? And I'm talking about energy management plan specifically that relates to water and wastewater treatment plants. If you have one, then we like to review existing plan if you like us to do that, and we can provide you some input in updating that if it needs updating. Also, if you don't have one, then we can assist in developing a more comprehensive plan if that's one of the requests that you all have to us. So very important. It's good to have an energy management plan for the water wastewater treatment plants. I think here we're going to reach the second poll question, which is, do your facilities have an energy management plan? If so, how often do you review and revise it? So the poll question will come up. It may be up on your screen already. We will leave it open for 10-15 seconds, and then we will close the poll, and then I will give you the results of the poll. Excuse me. All right. I think we're going to close the poll. All right. So it looks like 60% says yes, we review and update it frequently. Very good. 20% said yes, but it is old and outdated. Good, you have something, and it would be good if you can update that. And 20% said no, we don't have an energy management plan. So that's good to know. If you need any help with that, you can contact this SECO program manager, and we can go from there. So good. We'll move on to the next slide. Some other considerations on a water wastewater treatment plant is that you should be looking at premium efficiency pumps and motors. That's what we'll be looking at, seeing what you have right now and what could be installed over there. Using VFDs for soft start to pumping systems, so that's something that we'll be evaluating. Ideally, we want to look at VFDs more than a soft start kind of a device, as it has many useful applications. But anyways, when we're going through the facility, we look at those things. Compare cost of chemical to the cost of power, and this will be more explained later on by Bob to you. But there are some savings associated with using UV lights and so on and so forth, but we look at those aspects of it. And then we also look at controlled dissolved oxygen level, utilize off-peak energy demand pumping, so on-peak and off-peak pumping, demand pumping savings evaluation we look at. We may also, although in the PEA we are very limited to what we could do because of the time and expense involved in it, we evaluate pipe sizing and see if there's an opportunity to reduce friction and so on and so forth. Utilize leak detection systems, basically. So we are looking at leak detection. This has been in the last 3 or 4 projects that we've done, have been something that the cities have been wanting to look at. And then we also look at modifying the system operations, basically. So we might be asking questions about what kind of operations you have, and there might be an opportunity to improve that. To give you a quick example of that, not a specific example, but recently we were looking at a facility where we realized that the operator was actually doing much more than what this permitting requirements were, and according to him, he was trying to do a much better job at it, but when we did the calculation of how much energy was being used to do that extra, it became evident that that is something, the practice that they shouldn't be doing. So just by that one measure, it was close to, I believe, close to $30,000 to $40,000 per year savings of simple recommendations. So that's why we normally ask the system operations, modify those operations type of questions. And depending on what kind of facility we are looking at, there might be other measures. So well, technical assist, so what we are looking at is that you may have an air conditioning system on your offices, that we might be evaluating that, seeing if there are any leakage and stuff like that. So on the left side, you see a thermal image of where we have looked at an air conditioning which had leaks on the roof, and it was cooling the roof. Also, we'll be going, and our primary focus will be looking at the old equipment and visual inspection of the equipment, basically. So we'll be making notes on that and see what could be done to upgrade those things. The other things we want to be careful with, or which is very important, is that what you see on your screen is that you may have number of utility meters on your complex. What ideally we want to do is we want to kind of isolate the meter to the process or the buildings that is serving. Very important to do, so that you can have a fairly good idea of how much energy you are using at a particular process, or what energy use is associated with particular building, basically. So that's something, a meter mapping that normally is done also. And then again, operations and visual inspection of your operations is what will happen. One of the things that I would like to just quickly go over, what are the typical utility cost reduction measures, also called UCRMs and paybacks, in water wastewater treatment plants. So there are O&M measures we are able to identify from time to time, 0 to 1 year payback. Dissolved oxygen control, we have seen payback from 2 to 7 years, and for your facility it may be more or less, but these are some general ranges. High efficiency blowers have caught on and pretty common now, 8 to 12 years. Variable speed drives application, 8 to 15 year. Optimized aeration design. We've been able to provide some recommendations anywhere from 5 to 10 years. Power factor improvements, 3 to 8 years. Smart meter applications, mostly in the water side also, of anywhere from 5 to 8 years of payback. And application of leak sensing technology in the water mains and so forth, anywhere 1 to 6 years payback. And we've also from time to time evaluated if you are going to participate in a demand response program, then we look at that aspect of it and see what is the potential investment on your side, and then calculate the payback based on the utility incentive in that case. So typical utility cost reduction measures, you will see a range over there. That is one of the reasons that you want to do a preliminary energy assessment, so that you can actually nail that payback and that cost down. And that is one great advantage of doing a PEA, is that it will at least give you that basic information that you need as to what kind of measures are good for your facility. The next, I will just quickly give you some case studies of the PEAs, preliminary energy assessments that were later. Some of them were implemented, some are in the process of being implemented. But these are examples. So, City of San Marcos had a report done, basically close to $1.9 million. I think they actually went and used the Lone Star funds to implement these projects. So these are actual projects over there with 8.9-year payback and estimated utility cost saving of $221,000 per year. Important thing to keep in mind, that the city over there had looked at all their facilities that were not water and wastewater related also, but they also had a couple of measures, or we had a couple of measures at the water and wastewater plant also. So pretty comprehensive process over there. So that was City of San Marcos. In the PEA recently, City of Pharr had done a project in which we have mostly focused on water wastewater part of it. $1.4 million worth of project identified, with one very quick payback of 1.3 years, with close to $1 million a year savings, and most of them were coming from application of leak sensing technology and so forth. So again, from time to time you're going to run into cases where there could be a much more quicker payback. Another example, this was done maybe a year or 2 years ago, was City of, not City, but sorry, New Braunfels Utilities. We did a PEA over there, close to $9.7 million worth of projects were identified. It had an estimated utility cost saving of close to $1.5 million with a payback of 6.6 years. The type of projects that were looked at: coarse bubble to fine bubble diffusion, dissolved oxygen sensor application, variable speed blowers. But the majority of the project was evaluating citywide 5/8-inch water meter change out to smart meters and application of that technology. They were close to 30,000 meters or so, so there was some statistical analysis done over there. But that is a good example of a PEA done for a utility district, basically. So, and I understand that they allocated some money to do a prototype and may have been implementing some of these projects on their own. So these were the 2 or 3 case studies. Here I'm going to switch to Bob Tonhoff, that will go over the next couple of slides with you all. And so just bear with me for a second while we change seats over here. Thank you.
Very good. Hello, everyone. This is Bob Tonhoff with Tonhoff Consulting Engineers, and I'm here to talk to you about the various things we look at in water and wastewater facilities when we're doing these assessments. One of the first things we look at is your water pumping, and we look at your pumps and motors and try to determine if you're using high efficiency pumps and high efficiency motors. Typically, we've found that the maximum efficiency pump for water is in the 80% range, and the maximum efficiency motors are 94% range. Worst case are normally around 60% for a pump and 90% for a motor. And what we found is when your pumps are nearing their end of their useful life, it is best to consider replacing them with high efficiency pumps and motors. The cost is going to be just a little bit more, but you'll realize a savings of about 15% of your annual energy consumption. The other thing we look at is your pressure planes. When we go into a city, we expect to see that you're pumping into your lowest pressure plane, or perhaps your base pressure plane first, and to make sure that you only pump the amount of water needed to a pressure plane that pressure plane needs. We've seen instances where municipalities or water districts pump to the highest hill first and let everything flow downhill, which is a tremendous waste of energy. So we've done some basic calculations and found that you can save approximately $15,000 per MGD pumped per year per every 100 feet of head that you pump. The next thing we look at is off-peak energy demand pumping. Many municipalities have demand factors such that in the peak time of the day, when you're utilizing your big pumps and motors and filling up your reservoirs full of water, it might be best to do that in the middle of the night when other demand charges aren't there. So you would consider having a large reservoir that could handle a 24-hour supply and only pump to it and fill it during non-demand peak hours. Also, we found that if you utilize variable frequency drive pumping, you can minimize these demand charges and just steady state, keeping a water tank full using a VFD. And we found that your energy savings would be approximately 25% of the cost of pumping during the energy demand time period. This could save as much as $4,000 per MGD per year. When we look at your water treatment facilities, we look at whether you're utilizing the energy efficient pumps and motors, whether you're utilizing variable frequency drive units. We like to look at your plant's hydraulic profile and make sure you're only pumping your water one time and not having to have intermediate pump stations because a hydraulic profile is a bit off, or you add a unit process that needs you to pump the entire volume of water back to a unit process. We found that you could save approximately $1,500 per MGD per year per every 10 feet of head that you waste. Also, we look at comparing the cost of chemical to the cost of energy. Many plants might use chlorine, and they might mix chlorine with bubbles or aeration, and we found that aeration can strip chlorine from water real easily, and you're just wasting money using that type of mixing. So we look at that type of thing. In wastewater pumping, we look at similar things. For pumping, we certainly like to use the most efficient pump and motor for the application, but wastewater pumps are normally a bit less efficient than water pumps. And we found that the most efficient wastewater pumps range in the 70% range, and motors are always the same. The most efficient are about 90%. Worst case pumps are about 40%, and worst case motors are about 85%. So again, when your pumps and motors are nearing the end of their useful life, please consider replacing them with higher efficiency pumps and motors, and you can save approximately 10% of your annual consumption on pumping. In wastewater pumping, often we recommend using VFDs. and you could utilize a VFD in lieu of a soft start mechanism, which would reduce your demand startup amperage whenever a pump turns on and off. When you use the VFDs, it just simply does the same thing, but it keeps it. You can keep it running at a lesser motor speed and pump less water and pace your flow to your plant's capacity. We found that your potential energy savings are approximately 25% of your pumping cost during a demand period, and we've calculated you could save approximately $3,400 per MGD per year if you do this. In wastewater systems, we also look to see if you're on a gravity flow system primarily, or if you're on a pressure source system, and we'd be looking at energy savings of gravity flow compared to pressure systems, or how often you use a wastewater pump station. Many times, as cities develop, they simply add a pump station, a wastewater pump station, to a new development area in lieu of seeing if that area can be served by a gravity system and not requiring a pump station. And just a basic energy calculation, we've calculated that you could save approximately $10,000 per MGD per year per every 30 feet of head that you pump. When we look at a wastewater treatment plant, we'd also look at your hydraulic profile to make sure it is optimized and you're not pumping water to an elevation higher than needed. We'd look at optimizing your aeration design, fine bubble versus coarse bubble versus staggered aeration or whatever. We like to see the use of natural treatment processes because then you don't have to have any aeration. And these natural treatment processes could be stabilization ponds, sedation pond that use algae for treatment, or trickling filters that use the slime growth media. And that's just tremendous amount of energy savings using natural processes. Also, we would compare the cost of chemicals to the cost of power. And this is most reflected in using ultraviolet disinfection in lieu of chlorination, dechlorination. And then, of course, we'd look at controlling your dissolved oxygen levels and make sure that they are within the norms or at the low end of what you actually need to operate your wastewater plant. So in optimizing the hydraulic profile of a plant, typically a wastewater plant would have a main lift station, pump up to the aeration basin, and let it flow by gravity through the entire plant. So you'll have aeration, clarification, disinfection, and discharge. Rule of thumb, you only want to pump your wastewater one time at a plant, and your potential energy savings are approximately $3,000 per MGD per year per every 10 foot of head that you have to pump. We'd also look at optimizing the aeration design. We've found that transfer rates of different types of aeration can vary greatly. Coarse air bubble diffusers have a transfer rate of 1.5 pounds O2 per horsepower hour compared to fine bubble aeration, which is 3.3 pounds O2 per horsepower hour. Mechanical aeration typically runs a little better than that at 3.9 pounds O2 per horsepower hour. And the fine bubble with a full coverage area using these high efficiency VFD blowers can be as high as 6.6 pounds O2 per horsepower hour. So simply by changing from a coarse bubble to a fine bubble, you can use the same blowers and typically save about 50% of your annual electrical consumption for your plant in that aeration area. So this next slide is simply a photograph of a coarse bubble aeration basin. And the next shows a fine bubble aeration basin, how it has a fuller coverage of your flow area and not as much turbulence on the top of the water. The next slide is just an underwater photo of the difference between a fine bubble and a coarse bubble. The next slide is a typical plant that utilizes mechanical surface aeration. And these are simply mechanical surface aerators that both mix and apply oxygen or air into the wastewater. And the type of wastewater treatment that utilizes natural treatment processes, of course, include these facultative lagoons that have a stabilization pond, which is a deeper pond, followed by oxidation ponds, typically 2 of them, that utilize the blue-green algae for oxygenating and removing your BOD. The second natural treatment process is a trickling filter, which some people consider a process that's no longer used, but I want to say I saw a plant last week that utilized a trickling filter with both primary and final clarification, and they were hitting BODs below 3. And that is just an amazing natural process to hit a BOD level that low. Typically, in the trickling filters were utilized in the 1950s and 1960s, and they were utilized when the BOD had to be below a 30 milligram per liter. But now with today's technology and process design, they can really get a lot better than that. The third method of a natural treatment process is utilizing an anoxic zone for denitrification, and this is just simply an area where you do not have oxygen injected into the wastewater and allow the natural chemical process to strip nitrogen from the water, which you no longer have to use air or aeration to do that. Just a natural chemical process. In a wastewater treatment plant, the normal design criteria requires engineers to design your aeration process at a 2.0 milligram per liter dissolved oxygen. What we've been finding is that these plants can operate very well at DOs as low as 0.5 milligram per liter, and even some lower than that, and still meet their treatment process. So I've determined that the 2.0 milligram per liter is just a design criteria. When you're operating your process, you should probably be between the 0.5 and the 1.0 milligram per liter. And my general statement is anything over 1.0 is wasting power. So just keep that in mind. If you're trying to keep your plants at a 2.0 DO, that's too much. Cut it down to a 1 and see what happens, and then go as low as you can go before you start losing your treatment efficiency. You have a potential energy savings of about $1,000 per MGD per year per milligram per liter DO that you save. I've seen many plants in my career that were running at a 4.0, a 5.0 DO in the aeration basin, and that's just wasting power. So when we're looking at comparing cost of chemicals to the cost of power, one of the examples has been this ultraviolet disinfection. And the textbook cost-effective analysis is that within a 7-year period, UV, ultraviolet disinfection, will become cost-effective when compared to the chemical costs of chlorination and dechlorination. And it's probably better than that today. That might be an old term, but ultraviolet disinfection is becoming very efficient with energy usage and very efficient when compared to chlorination, dechlorination. And the other example of wasted chemical costs are plants that use air bubbles to mix chemicals in your chlorine contact zones. We found that when you use that type of mixing, you're stripping your chlorine out of your water and probably utilizing twice as much chlorine as you need to. And so we've been recommending that you replace your bubble disinfection with a mechanical type mixer or a submersible pump that would mix it underwater with no bubbles, so that chlorine will not be stripped from your wastewater, and you'll get the full benefit of your chemical.
All right. Thank you, Bob. This is Salim again, and I just wanted to go over a couple of ways you can fund some of these projects, basically. And typically these are covered in more detail in the preliminary energy assessment report, but just like to point out 3 very relatively popular ways to fund these projects in for water wastewater plant. So the State Energy Office, SECO, has the Texas Lone Star program, which is a low interest revolving loan program, has been there for more than close to 28 years, a very successful program. You can actually go to the link and find more about it. Also, the Texas Water Development Board has got some sort of revolving loans also, and I understand that the U.S. Department of Agriculture has a program also. And Bob, you may want to provide support.
Yes, on the United States Department of Agriculture funding, it's typically for municipalities under a 12,000 population. So just keep that in mind. The municipalities with larger populations would not receive that funding.
And this SECO Lone Star program is open to all. And whether you're big or small, basically. However, you need to look at, they have a funding limitation of it changes from year to year, or from what they call when they announce the NOLFA, but it's open to pretty much all public entities. So just wanted to let you all know about this, and I will see if we have any questions. Just again, very quickly, my name is Salim Khan. My information is in the bottom left side over here. Stephen Ross is the program manager for the schools and local government program. His information is in the middle. Tonhoff, who's a sub-consultant to TEESI, to us, his information is on the right side. And typically when we're dealing with water and wastewater plants, me and Bob Tonhoff will group together, put our heads together, and then we take care of individual measures and ECRMs and jointly work together to come up with solutions, basically. So at this point in time, I think we will open, if there were any questions. We are doing much better than I anticipated, so we may be finishing up early, but right now I will, if there are any questions, feel free to ask them. If there are any questions, I'll just go quickly check if there's a question. So we'll start answering some of the questions. One of the questions typically that asked is that what is the time frame for a PEA? So a PEA normally will take anywhere from 30 to 45 days. It is largely dependent on how soon we can schedule some of these things, and also how soon we can get utility data information, so it is dependent on certain factors that are not in our control, but typically you take anywhere from 30 to 45 days. And then the typical question is that what is the difference between the PEA and a DEA? A PEA is a preliminary energy assessment, a DEA is a more comprehensive energy assessment. So if you're looking for a funding source such as a state Lone Star program, or if you're doing a private sector funding with a performance contract or anything else, then normally an investment grade audit will be required. But the PEA is a valuable planning tool that if you have done a PEA, you will have a very good roadmap, and you can use that information to actually reserve funds if you're going to apply for the Lone Star program. So a lot of time people have taken the PEA and actually applied for loans or grants or for their own budgeting process, basically. So I just wanted to make sure that that's covered. Let me see if there are any other questions popped up.
Okay, this is Bob Tonoff again. We had one comment regarding the ultraviolet disinfection costs of the 7-year payback. It was just a comment regarding whether to use the low pressure bulbs versus the high pressure bulbs. And the comment was essentially buyer beware of the high pressure because they utilize a lot more, or they use a lot more electrical power than the low pressure. So typically in my wastewater plants, we're using low pressure bulbs and a medium pressure, and we always compare the costs of power with the manufacturer's recommendation before we'd recommend it. So I've never used the high pressure UV bulbs yet, but that is just something to be aware of. Make sure you get all the manufacturer's recommendations on power savings before you go to a certain type of ultraviolet disinfection bulb.
So looks like we had most of our questions answered, and we are at least 20 minutes ahead of time. So that's good. We had allocated more time for question and answers, but it looks like we went through the presentation as we had planned, and you may have questions, follow-up questions later on. Feel free to email us. We'll be glad to go over and answer those questions to you all. Again, at this point in time, I think if there are no more questions, I would just recap what we covered basically over here. And again, a bookkeeping kind of a measure is that you all will be getting the PDFs of this presentation, and you will also be getting the video recording of this presentation. It might be a day or two delayed, but you will be getting those. And also we will be sending out the PEA request, which is a one-page document. In fact, what I like to do, if you don't mind, I'll try to put that document up there because a lot of time people have asked a question or two, and I like to see if I could just show you what that service request document looks like. Okay, I'm hoping that you could see on your screen let's see, there we go. Okay, so it is a one-page document, the service request document from the State Energy Office. Primarily in the top portion is your basic information, email address, entity, so on and so forth. You'll see the preliminary service request eligibility. It says the State Energy Office provides free preliminary energy assessments, PEs, for existing public facilities and infrastructure. Eligible entities include municipal and county governments, public school districts, county hospitals, port authorities, major airports, public water authorities, and municipally owned utilities. And leased or rented facilities and infrastructure are not eligible for this service. So the eligibility for taking part in this PEA is pretty much outlined in this one-page document. A lot of people have concerns as to what kind of agreement is this or what is their commitment. So they have also outlined the commitment in 5 or 6 bullet points. It says by submitting this request from the entity listed above must agree to select a contact person to work with SECO and its designated contractor to establish an energy policy and set realistic energy efficiency goals. Allow SECO designated contractor to provide walkthrough assessment of selected facilities. Schedule a time for SECO designated contractor to make presentation on the assessment finding to key decision makers. Consider implementing the PEA energy savings recommendations. So consider implementation, not required, but we expect you all that will take the advice and look into implementing these measures, and allow SECO to post portion of this report on its website. Most of the SECO reports, the PEA reports, you will find them on SECO's website. So then recently some additional questions have been added. So the additional questions are pretty much yes and no question. Has the organization used SECO technical assistance or PEA service in the past? Yes or no? Is the primary contact for this PEA familiar with SECO Lone Star revolving loan program? So primarily the revolving loan program is a program, if you're familiar with, and then you can do yes or no. And has the organization used SECO Lone Star revolving loan program in the past? So you can answer yes or no, and then the signature is that this agreement must be signed by your organization chief executive officer or other signing authority. So it is ideally it should be someone in the finance or chief executive, but it could be anyone who has the authority to sign this thing. So you sign, send it to the address in the bottom left over there, which is Stephen Ross, the SECO program manager, and then you can mail it, or nobody mails it anymore, but you can surely mail it, or you can scan it and email it. If for any reason you send it to one of the engineering firms doing this, then they will have to send it to the SECO also. But a very simple form, one-page form, a free service provided by State Energy Office. If you can fill this information and if you feel you're eligible for it, the eligibility criteria is already provided in this one-page form, then you can sign and turn this in and get this service signed up. So I just wanted to make sure that I go over this form to you all too. And if there are any questions, you all could feel free to either call me, or you can just call Stephen Ross and get your question answered on this form too. So I hope everybody was able to look at this this form also. And I think with this, I'm going to go check one more time to make sure that there are no additional questions. If there are no additional questions, which I've been told there are no additional questions, so I'm going to close the webinar over here. And from me and Mr. Bob Townhoff, and on behalf of the State Energy Conservation Office, I'd like to thank everybody for attending this, and feel free to contact us with the follow-up questions you have any. And I'll say good afternoon. Bye-bye.